All right, welcome back. We're going to jump right into the second day of 11.1. Again, like these numbers are sections in the book. Doesn't really mean a whole lot. I want to focus more on what the actual topic is that we're covering. So we're going to continue the discussion from last time. Today we're going to talk about permutations and combinations. So we'll discuss what those are and how they allow us to count. Our EQ is how can I use permutations and combinations to quickly count possibilities. So in part 1 of 11.1, we talked about the fundamental counting principle. And then in this video, we're going to talk permutations, combinations, and how they kind of differ. So as a quick warm-up, local flower shop has 3 types of flowers: roses, daisies, and chrysanthemums. Each flower comes in one of 4 colors, and they are available in a bunch of 6, 12, 18, or 24. How many different flower bouquets does the shop sell? So if we think about what we did in the last video, or in 11.1.1, we said this flower shop, or when you go to the flower shop, you have 3 decisions you have to make. What kind of flower do you want? What color would you like that flower to be? And then how many or what size do you want the bouquet to be? So we have 3 options, or 3 decisions, I guess, that we need to make. How many flowers? There are 3 different possibilities for flowers. There are 4 color options to choose from, and there are 4 bouquet sizes. Fundamental counting principle tells us I can multiply all those together. 3 times 4 is 12, times 4 is 48. So there are 48 different bouquets. Now I'm second guessing how I say it. Bouquets. All right. So that was kind of what we covered in 11.1.1. But what we're going to talk about today is a permutation. Okay. And so a permutation is an arrangement of items in a very specific order. So if I were to line up, 5 advanced algebra teachers, and then that would be one arrangement. So we'd line up from left to right. If 2 people switch spots, that would be considered a different arrangement. Even if the first, second, and third person in line were all the same, if the last 2 people switch places, that would be a different arrangement or a different permutation. Okay. So a phrase you're going to hear a lot is, with a permutation, order does matter. The order that you stand in does matter. So here it says 8 runners are competing in a 400-meter dash. The top 3 get medals: gold, silver, bronze. How many different arrangements are there of the top 3 finishers? And so I want to kind of start this. If you see the word arrangement, you should automatically be thinking permutation, which might seem silly now, but it'll help later on. So how many different arrangements are there of the top 3 finishers? So just like we did prior, we have 3 people getting medals, or there are 3 medals to be handed out. There's gold, there's silver, and there's bronze. And the first medal that's handed out is gold, because whoever gets first place in the race gets gold. So there are 8 possibilities for the gold medal winner. Then of the remaining 7 racers, one of them will get silver. And then of the remaining 6 racers, one of them will get bronze. Okay. So fundamental counting principle tells us I can multiply those 3 numbers together and get 336 arrangements or permutations. Okay. And again, obviously this is a permutation, because if you finish first versus finishing second, that's a different outcome that matters to you. So that's why we have 8, 7, 6. So another example of a permutation is, let's say in baseball there are 9 batters, and a coach needs to put a lineup together of 17 players. Okay, so what we could do is I could say, oh boy, iPad issues. I could say there are 17 people to choose from, but there are 9 slots: 3, 4, 5, 6, 7, 8, 9. And who bats first? Well, the coach has 17 options. Who bats second? 16, and then on down the line, 13, 12, 11, 10, 9. Okay. Now I could type all that in the calculator, but there's actually a quicker way to do this that I'm going to show you right now. And that is this. I can't use factorial with this, because if I do, so in the previous video, we talked about this factorial thing, the exclamation point, and that is multiplying every number from 17 down to 1. And obviously I'm not doing that here because I don't have 17 players, or I don't have all 17 players in the batting order. I have only 9. But in that same menu, we do have an option to do a permutation calculation. So basically what's happening here is I have 17 players to choose from. It's a permutation because the order matters. I'm looking for arrangements. And I'm choosing 9 people, choosing 9 batters, essentially, of the 17. So I can actually type this in the calculator by putting 17 first. How many am I choosing from? I go to the math menu. I can go over to the probability tab again. And then this second option right here, this NPR, if I click enter on that, you can see how 17 kind of got small there, and then it's looking for another number. This is now saying, of 17 people, how many are you picking? And I'm picking 9 to be in the batting order. So how many different arrangements or how many different lineups could there be? There are a lot. 1, 2, 3. So it's 8,821,612,800. It's a ton. But the point here is that this typing 17P9 into the calculator will get you the same thing as if you were to type 17 times 16 times 15 all the way down to 9. Okay, that will give you the same value. So if I do the same idea here, if I select 5 random letters from the alphabet and there's no repeats, okay, so if I pick the letter A, can't use A again. Well, I have 5 letters to choose, 5 decisions. First letter is 26 possibilities, then 25, then 24, 23, 22. Again, rearranging 2 letters changes the word, right? If you switch the order of letters, that changes what the word looks like. So that's why we have a permutation. So of 26 letters, I have a permutation of 5 of them. I'm trying to find how many different arrangements there are. So again, in the calculator, I can say of 26, hit the math button, go over to the probability menu, NPR 6. Nope, not 6, 5. So if I'm only choosing 5 letters from the alphabet, there are 7, 8, 9, 3, 6, 0, 0. There's 7,893,000 different ways to do that. So a ton. But again, the point is that what we just typed is quicker than doing this. This is the only time I'll do this in this video or at all. But I just want to show you that you can get the exact same answer, just typing it by hand. Okay. So let's say you and 3 other finalists are applying for an internship for a summer job. Okay, how many different pairs or duos can be chosen for the positions? So there are 4 people. Okay, and the question is how many different duos can be picked. And so I've numbered the people 1, 2, 3, 4. If this was a regular classroom, we would have had a fun little interactive thing to do with this, but one possibility that could happen is person 1 and person 2 get the job. I could do person 1 and person 3. I could do person 1 and person 4. Okay, those are all the possibilities that have person 1 being picked first. I could do 2 with 1. I could do 2 with 3, and I could do 2 with 4. Okay. I could do 3 with 1, I could do 3 with 2, or I could do 3 with 4, and finally 4 with 1, 4 with 2, and 4 with 3. So the answer is 12, right? Some of you may be kind of talking back at me on your iPad or whatever you're watching this on, but 12 is not the correct answer. And the reason is these 2 quote-unquote possibilities are actually the same thing, right? person 1 and person 2 getting it is the same as person 2 and person 1 getting it. Like rearranging those numbers doesn't actually lead to a different outcome. So I'm going to go ahead and eliminate all of the duplicate possibilities. So 2 and 1 was already there. 1 and 3, so I don't need 3 and 1. 1 and 4, so I don't need 4 and 1. That's a duplicate. That's a duplicate, and that's a duplicate. So there aren't 12 possible pairings of interns. There's actually only 6. 1, 2, 3, 4, 5, and 6. Okay. 6 pairs. I'm going to use pairs. Okay. And this is a pretty important distinction in that the answer wasn't 12 because switching the order doesn't result in a different outcome. And that's what we call a combination. Okay. A combination is a selection of items where the order in which you pick them does not matter. A good example of this is if you order pizza. Okay. Now, not too often do you call in pizza. Most of the time it's online. But if you have a coupon for a 3-topping pizza and you can choose chicken, sausage, mushroom, or peppers. Okay. For some reason, those are the only 4 toppings. And you want to use all 3 toppings available to you. How many different pizzas can you order? Well, if you picked chicken, sausage, and mushroom, it's a weird pizza. What we have to understand is that's the same as saying chicken, mushroom, and sausage. Right? Those are the exact same pizza, even though the letters are rearranged. And that's the difference between a combination and a permutation, is that with a combination, the order in which the items are listed doesn't change the outcome. So I can't figure this problem out the same way that I've been figuring out the other problems. I could do, besides chicken, sausage, and mushroom, if I think about another pizza I could make, I could do chicken, sausage, and peppers. I could do sausage, mushroom, and peppers, or I could do. Isn't there a fourth one? Mushroom. Come on. Chicken. Oh, and then chicken, mushroom, and peppers. Those are my only 4 options. Okay, so I actually only have 4 possibilities for this pizza where there's 4 toppings and I'm picking 3 of them. This is what we call a combination, and this is where I could use the calculator and say of 4 toppings, I'm doing a combination with 3 of them. Okay, and again, I can do the same thing on the calculator. I can go for math. NCR is the same idea as the NPR button I showed a little bit ago, but if you recognize that the order in which items are selected doesn't matter or doesn't change the outcome, we're going to use NCR. And if I do 3, there we get the 4 pizzas. Now, just to show real quick, if I were to accidentally misconstrue this and decide that this is an NPR problem, I'd have way more possibilities, 24. And there's not 24 different pizzas, because that would mean that switching the order of the toppings switching the order in which you say the toppings would lead to a new pizza, and that's not the case. All right, enough of that. Let's move on. At a speech competition of 6 students, the top 3 are going to move on to the next round. How many sets of students could move on? And so the big question here is, does the order in which you're selected matter? And you might initially say to yourself, well, yeah, it matters. I want to be picked first. But if you're picked first, what's the outcome? You move on to the next round. If you're picked second, what's the outcome? You move on to the next round. If you're picked third, you move on to the next round. So the order in which you're chosen doesn't actually lead to a different outcome for you. So this is an example of a combination. Okay. Order does not matter. Oh boy. Order does not matter. So I'm going to use the combination button on the calculator to get this figured out very quickly. How many students am I picking from? 6. And then I have a combination, and how many are we choosing to move on to the next round? I'm choosing 3. So 6 combination 3 in the calculator, 6 math 3. there are 20 different groups of 3 that could move on in this competition. Okay, and again, if I were to do 6P3, the number would be much higher. I believe it'd be 120. Okay, so it's quite a bit different there. So what it comes down to is, does the order matter in the situation you're looking at? Does being picked first versus second versus third change something for you? And that's where I decide if it's a permutation or a combination. Okay. Does the order you finish a race matter if medals are handed out? Yeah, if medals are handed out, I want to be first because I want gold. So since the answer to this is yes, that means I have a permutation on my hands. Okay. So I'd use that NPR button. The exact same question, but if I change it to, you are not, there's no medals, but you're qualifying for the next round. If you're a track athlete, right, this is the prelims qualifying for finals. While you'd love to be first, it really doesn't matter because you advance to the next round. So this is a no, which means I have a combination. Okay. I'm going to use that phrase a lot. Does order matter? Does order matter? Again, just kind of a summary of what we've done. Okay. Permutation, order matters. The first number is the N is the number of items you are choosing from, or the number of options you have. And then R is how many you are choosing, or what we would have had the slots from earlier. A combination is, of course, when order doesn't matter, but the N and the R are the same thing. Okay. At this point, go ahead and pause the video, give these 2 a shot, and come back when you're done. How many different groups of 8 can move on to the final heat of a competition if there are 16 competitors? Okay, and I circled final heat because since we're moving on to the final heat, medals aren't being assigned. This is a combination. I'm just going to put com. Okay, so how many are we choosing from? 16, and I want a combination of how many of them? Well, I want 8 to move on. So 16 math and CR is the third option. So there's 12,000, oh boy, 12,870 different combinations or groups of 8 that can move on to the final heat. And then how many ways can a president, VP, and treasurer be chosen from a student council? Now here, because there are assigned roles, president, you being chosen first as president versus second as vice president versus third as treasurer is a different outcome. So I have a permutation on my hands. Okay, this is a permutation. How many options do we have? We have 12 students. A permutation of 3 of them leads to how many different possible cabinets or groups of officers? Nope, I want to be over in the probability menu. Oh boy. Dear Lord. NPR 3. I have 1,320 different possibilities. Okay. So to summarize, how can I use permutations and combinations to quickly count possibilities? It really comes down to, again, this idea of NPR and NCR. Okay. I'm basically gonna point you back a couple slides prior where we laid this out. Biggest thing here is that with a permutation, order matters. And with a combination, order doesn't matter. Order doesn't matter. And that'll about do it for permutations and combinations. So make sure you like and subscribe. Did I say that right?